All right, folks, here we go again. This is about my third try. After about 10 days, the good news is a new computer is still on the way. If this quality is usable, the new computer will be here, and the quality will even be better. So what I want to do is review pages 5.6 and 5.7, basically reviewing how we identify different types of reactions. So I'm starting at the bottom of page 5.6. And what we said was, when we were looking at reactions 10, 11, and 12, we said, well, that's weird. There's elements alone. That's our hint about, the focus just went bad. So that's our hint about recognizing these as redox or oxidation reduction reactions. So that was our first hint. But then reaction 13 looks kind of funny. There aren't exactly elements alone. There are elements as ions. There's gold 3 ion, gold 1 ion, iron 2 ion, iron 3 ion. Now, what we noticed here was the charges are changing. 3 plus to 1 plus, 2 plus to 3 plus. And you might think, well, I don't really see that in reactions 10, 11, and 12. But the truth is, here's a trick question for you. What's the charge on iron? 0. What's the charge on copper? 0. Sodium, chlorine, oxygen. Elements alone have a charge of 0, right? They're neutral. No more protons than electrons. So I'm going to bounce over to page 5.7 here. And we'll say, well, what we noticed, trying to find a pen that works. What we noticed is elements alone. So elements not in compounds. And the other thing we noticed was somehow the charges change. Now, what would be exchanged that would make charges change and would make elements alone with a charge of 0 have a different charge when they're in a compound? What's being exchanged that would make charges change? Electrons. That's the mechanism. Here's how we recognize a redox reaction. And the mechanism is somebody's giving up electrons and someone is gaining electrons. So let's go back to page 5.6 again and look at acid-base neutralization reactions. What we noticed here was, we could start, there's my red pen, we could start by saying, well, gosh, I remember those are acids back from chapter 3. And what we're really talking about here is H+. Okay, well, I recognize those in an acid. Over here from chapter 3, we said, oh, those are all hydroxide, OH-. So there we were from chapter 3. Now we have something a little bit different going on here. So we'll have to come back and sort that out later. But one of the things we said was, every single time we get an ionic compound, every single time there's an acid-base reaction in Chem 51, there's an ionic compound that forms. The other thing we said was, gosh, every single time water was formed. And sometimes, not always, but sometimes we get CO2. So we said, okay, well, I see an acid over here. I'm not exactly sure about the base part here, but hydroxide I know from chapter 3 is a base. I'm always getting an ionic compound. I'm always getting water. And sometimes I get fizzing from CO2. So if I go back to page 5.7, there's my acid and base. And so I think H+ for my acid. A base, Professor Paula Abdul would say, if H+ is coming from acid, what do you think the charge might be on the base that would make them react? Well, I'll leave that up to you for a minute. We'll come back to that later. But one of the things we noticed was I always get an ionic compound, and I always get water, and sometimes we get CO2 gas. So there's I look for an ionic compound, water, and CO2. I look over here for a hint for an acid. I might look for something like OH minus is a base that we've seen. And I really need to have all of those things, except of course the CO2, which may or may not happen. But I need to have all of those things: an acid, a base, ionic compound, and water for it to be an acid-base neutralization reaction. Well, what's being exchanged here? And I've sort of given a hint like, gosh, if the thing from acid is H plus and it comes off of the acid and there's something minus, Professor Paula Abdul would probably predict that. So what's being exchanged in an acid-base neutralization? H plus. So this is how I recognize it, and here's the mechanism. Let's go back to precipitation reactions on page 5.6. And we said, oh yeah, okay, I recognize the aqueous, 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 aqueous. On the reactant side, everything is aqueous. And what I notice on the product side is at least one solid. You can actually get two solids, but there's at least one solid. And now what I want to know is, okay, what's happening? Well, let's pick, say, this silver nitrate and sodium chloride. There's silver nitrate. Silver nitrate. Let me circle that one in blue. And over here is sodium chloride. And when I get over to this other side, I notice, oh, the silver is with chloride over here. The sodium, formerly with chloride, sodium is now with nitrate over here. So let's go to page 5.7 and summarize this. We get all aqueous reactants. And we get at least one solid. And what's being exchanged? Well, remember, if we go back to this, I say, well, gosh, silver used to be with nitrate, and sodium used to be with chloride, and over here, silver's with chloride, and sodium's with nitrate. Remember, this is like 8th grade. Like every week, the boys and girls or whatever are breaking up and they're with somebody else. So what's being exchanged there? Ions. So there's the mechanism, mostly the mechanism. And here's how I recognize it. All aqueous go into at least one solid. And how do I know if that's going to happen? Well, I can go back and look at my solubility rules and look at the ions and decide, are these ions that are going to stick together and form a solid? Or are these ions that are going to stick to water and remain aqueous? Now let's go down here then and identify these as acid-base, precipitation, redox reactions. Now these are problems 5.7 and 5.14 right out of your book. So all of these examples that I try to do in lecture, the answers are in your book. So you're able to go back and double check. Maybe double check my work, I don't know. So if I look at this first reaction, and I see, well, aqueous, solid. Well, let me say this. What I should have said, I'd edit this out if I knew how. What I'm going to say is, pause the video for a minute, go through A through B, A through C, and A through C, and see if you can identify these as what type of reaction. Then restart the video and come back and you can see the answers that I'm going to provide. Or you can go to your book and look at page 5.7, 5.14 in the back, in the appendix in your book, and the answer's there. Okay, pause the video, try these, then restart it, and I'll go through the answers. Okay, nice work. You're back. So aqueous, aqueous, at least one solid. That's kind of the easy one. Precipitation. Easy to recognize. Maybe kind of easy to recognize. The next one I see an element by itself. Immediately I know redox. Down here I see, well, gosh, that looks like it might be an acid. There's water. There's an ionic compound. Over here I remember, oh yeah, that's right. That's old hydroxide. So I say, okay, that's acid-base neutralization. I go down here to this other A. I see an element by itself. I stop and say, redox reaction. Now, of course, it can be more complicated. You could have multiple types of reactions going on. We're going to mostly avoid that in Chem 51. So as soon as I see an element by itself, I say, oh, that's it. I'm stopping. I'm not going to look for anything else. That's redox. Down here, I'm seeing, oh, that looks like acid. There's hydroxide. There's an ionic compound. There's water. Bingo. Acid, base. This, aqueous, 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 aqueous. Not precipitation. I don't see any water formed. I don't see any H plus over here. I'm thinking, nope, it can't be acid base. So I'm somehow left with redox, and it's not obvious. But if I start thinking about this, okay, that's iron 3 plus chloride. That's tin 2 plus and chloride. On the other side, I've got iron 2 and chloride and tin 4 and chloride. Oh, bingo, there it is. Charges have changed. And we've got a redox reaction. Okay, let's see. So that sort of wraps up the reintroduction to reaction types. I can't find my notes in front of me to figure out what I was going to do next. But anyway, that wraps up sort of recognizing reaction types. And I apologize for not knowing exactly. Oh, excuse me, here it is. The next segment is going to be predicting products for acid-base neutralization reactions. So let's keep our fingers crossed that this works, and I will see you at the next lecture segment, which is page 5.11. Okay, bye for now.